Hi class, this is over section 6.4 and 6.5. I know it doesn't say 6.5. It's special parallelograms. So today we're going to go over rhombuses, rectangles, and squares. First, I want you to draw a rhombus that is not a square. To draw a rhombus that's not a square, you would need to draw an actual, just a rhombus, because technically a square is a rhombus. But for a rhombus, what we're looking for is that the angles are not 90 degrees, but that all sides are congruent. Draw a rectangle that is not a square. So for the rectangle to not be a square, you need to have different lengths for your width and your height, or if you want to call it your length and your width, however you want to say it. But these sides would need to be congruent in a separate length than these two sides that are congruent. If all four sides of this were congruent, it would be a square. So I've gone through and explained already why each is not a square. Theorem. If each diagonal of a each diagonal of a rhombus bisects two angles of the rhombus, so the opposite angles. So looking at this figure right here, we're going to go ahead and try a proof. So let me just go over what this says before we do the proof again. Each diagonal of a rhombus, so here's a diagonal of a rhombus, it's going to bisect two angles of the rhombus. So see how this diagonal is bisecting angle H and angle A. That means angle 1 and 2 would be congruent, and angles 3 and 4 would be congruent. So given rhombus MATH, we are going to prove that segment HA bisects angle MAT and MHT. So at first we're given a rhombus, so I'm going to mark that. I know that angle 1 and angle 3 are congruent because if you look, this is an isosceles triangle. If the sides are congruent, then the angles across from the sides are congruent. I also know that 2 and 4 are going to be congruent because these sides right here are congruent. So I'm going to mark that in my picture. I know that angle 2 and angle 3 are congruent because since this is a rhombus is also a parallelogram, because remember it's underneath the parallelogram on the quadrilateral tree. I know that the alternate interior angles are going to be congruent because these sides are going to be parallel. So MA and HT are parallel, which means angle 3 and angle 2 are congruent. The same thing goes for the other sides. MH and AT are going to be congruent, which is going to make angles 1 and 4. MH and AT are going to be parallel, which is going to make 1 and 4 congruent. Then by substitution, I can say that angle 1 is congruent to angle 2. The reason I can say that is because 1 is congruent to 3 and 2 is congruent to 3, so these two can be congruent. The same thing happens over here. I can say 3 is congruent to 4 because 2 is congruent to 4 and 2 is congruent to 3, which would make 3 congruent to 4. So, knowing that, I know that segment HA is bisecting those angles because I just shown that angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4. Theorem. The diagonals of a rhombus are perpendicular. So if you were to draw in both diagonals in your rhombus, the point where they meet would create 4 right angles. That's what perpendicular means. It creates 90-degree angles. The figure is a rhombus. Find the measure of each numbered angle. So I know this angle is 70 degrees. I have to find 1, 2, 3, and 4. Well, I know that this is an isosceles triangle, which means that these two angles have to be the same right here. So if I do 180 minus 70, that gives me 110, which means that these two angles, you're going to divide 110 by 2 and get that each of them are 55. Then I know that 2 and 4 are going to be the same as 1 and 3 because the diagonal bisects. So if 1 is 55, then 2 has to be 55. And if 3 is 55, then 4 has to be 55. Alright, over here it's going to be a little bit harder because we're almost finding every single angle. Let's start off with angle 8. I know that angle 8 is going to be 24 because we know that the diagonals bisect. So if this is 24, that has to be 24. I also know that 6 is 24. There's two ways you could say this. This right here is an isosceles triangle, so if one base angle is 24, the other one's going to be 24. Or you also know, since this is a parallelogram, that opposite angles are congruent. So if this whole angle is 48, this one would have to be 48, which would make both of these 24. So there's a couple ways you could get your answers. So I also know that 7 is going to be 24. I know angle 5 is going to be 90 because of this theorem up here. Angle 1 is going to be 66. I found that because if this is 90 and this is 24, I know these have to add up to 180. So I subtracted those two from 180 to get that this is 66. That means angle 2 is 66. And that also means that angles 3 and 4 are 66 because they're across from it up here. Theorem. The diagonals of a rectangle are congruent. Find the lengths of the diagonals in rectangle LMNP, given that LN is x plus 16 and MP is 2 times x plus 2. So LN is a diagonal and MP is a diagonal. Since this is a rectangle, they're going to be congruent. So I'm going to set them equal. I distribute and find x. And you get that x is equal to 12. It says find the lengths of the diagonals, so I'm not finished with this problem. You would then need to plug in your answer to find the actual lengths. So LN is going to be 28 and MP is going to be 28. You should get the same answer for both these because they're supposed to be congruent. So if you are ever doing a problem with a rectangle and you don't get the same answer for each diagonal, you need to go back and check your work. Some more theorems. If one diagonal of a parallelogram bisects two of its angles, then the parallelogram is a rhombus. That's just the converse to a theorem that you guys learned earlier about the rhombus and how the diagonal bisects. If the diagonals of a parallelogram are perpendicular, then it's a rhombus. And if the diagonals of a parallelogram are congruent, then it's a rectangle. So this is just the converse of each of those theorems that you've learned. What would you call a parallelogram whose diagonals are congruent and perpendicular? So what would you call a parallelogram that's both a rhombus and a rectangle? You would call it a square. Alright, so let's try some problems. Quadrilateral RSTU is a rectangle. If the measure of RTU is 8x plus 4 and SUR is 3x minus 2, find x. Well, since it's a rectangle, I know that the diagonals are congruent and they bisect each other. So that means that all four of these are going to be congruent. So that angle right there is 8x plus 4 and this one is 3x minus 2. These don't really have a relationship right now. But I know that this angle right here is also 8x plus 4 because this is an isosceles triangle. So now these two angles have a relationship. They add up to 90 degrees because a rectangle has all 90-degree angles. So we add those up to 90 degrees to get that x is equal to 8. Quadrilateral EFGH is a rectangle. If GH is 6 feet and FH is 15 feet, find GJ. So here we have GH is 6 and FH is 15. We need to find GJ. Well, I know that all of these are going to be congruent. So each of these is going to be 7.5, which means that these two are going to be 7.5. if zx is equal to 6x minus 4 and wy is equal to 4x plus 14, find zx. I want you to try this on your own. The answer is 50. If wy is equal to 26 and wr is equal to 3y plus 4, find y. Try this on your own. The answer is 3. And let's see if you met the target. KOMS is a rhombus. I want you to list 3 properties of KM and OS. See you in class.